In this problem, we have this member that is subjected to 3 different forces, and this problem has several parts. For part A, we need to determine the resultant moment produced by these forces about point A. For part B, we need to do the same, but about point B. And then for part C, we need to replace this loading system by a single resultant force and specify where its line of action intersects the segment AC. So I'm going to go through part A and B quite quickly because this is something you've done before. So for part A, to determine the resultant moment produced by the forces about point A, we're going to use the principle of moment. So F1 has 2 components. The X component passes through point A, creating no moment about point A. So only the Y component, in this case, that is negative 250 times cosine 30 degree times 2, that's the moment arm. Negative sign because it creates clockwise rotation about point A. We follow convention. Counterclockwise is considered as positive moment. Therefore, in this case, this is a negative moment. And then for force F2, same thing. It has 2 components, an X component passing through point A, creating no moment, and a vertical component also creating clockwise rotation about point A. So its vertical component is 300 times sine 60 degree, and the moment arm is 2 plus 3 meters, so overall 5 meters. And for force F3, it also has 2 components, X and Y components, and both of them create moment about point A. So for the X component, it creates a counterclockwise rotational effect, so it's a plus 500 times 3 over 5, that's the X component, times the moment arm of 4 meters. And lastly, its Y component creates a clockwise rotation, so that's negative. It's 500 times 4 over 5. The moment arm is 2 plus 3 meters. So as a result, this equals to negative 2,530 Newton meter. If you want to, you can convert that into negative 2.53 kilonewton meter. So that is the answer to the first part of this problem. And then I'm going to do the same thing for point B. For point B, again, F1 has components X and Y. Both of them have moments about point B. So the X component, so resultant moment about point B, X component is 250 times sine 30 degree, and it's creating a clockwise rotation about point B, so negative sign. The moment arm is this one right here, 4 meters. The Y component, vertical component, is creating a counterclockwise rotation about point B. So the magnitude is, so it's positive 250 times cosine 30 degree, and the moment arm is 3 meters. And then for point C, for force F2 at point C, it has 2 components, X component and a Y component. The Y component passes through point B, creating no moment about point B. Only the horizontal component creating a counterclockwise rotational effect about point B. So it's plus sine 300 times cosine 60 degree, and the moment arm is 4 meters. So that equals to 750 Newton meter. So that's the second part. Now moving on to the third part. For the third part, the problem asks us to determine, to replace the loading system, replace these 3 forces by a single resultant force To do that, we're actually going to first replace this system by a one force, one moment system. And how do we do that? We're going to basically determine the resultant force as well as the resultant moment. In this case, we have the hint that it's measured from point A. So we're going to determine the resultant force and the resultant moment about point A. For the resultant force, along the x direction, we have x component from F1, so that is 250 times sine 30 degree. A component from F2 along the negative x direction, minus 300 times cosine 60 degree. And lastly, x component from F3 along the positive x direction, then that is 500 times 3 over 5. And that equals to 275 Newton. That's along the x direction. Resultant force along the y direction equals to, we have vertical down, that's 250 times cosine 30 degree negative. And then F2 has a vertical down component that is 300 times sine 60 degree. And lastly, another vertical down component from F3 that is 500 times 4 over 5. So eventually that equals to negative 876 Newton. Therefore, the resultant force has a magnitude of 275 squared plus a negative 876 squared, and that equals to 118 Newton. And then the resultant moment about point A, we just determined it, and that is, we're going to use this number because of consistency in unit, negative 2530 Newton meter. So what does that mean? It means that we can replace the original 3 forces by a one force, one moment system. This force, and we can place that at point A because we summarize the moment about point A. So the force is represented by a force with magnitude of 918 Newton, but what about its direction? Its direction is determined by its x and y component, that is a 275 along the x direction, and then negative 876. Therefore, that force with a magnitude of 918 Newton. You can determine the angle if you want to, and that angle is simply arctangent 876 divided by 275. So that's my FR. And I need to also put a moment, a free moment here, and that is clockwise because it's negative 2530 Newton meter right here. At this point, I have replaced the system by one force and a couple moment. But because this force and this couple moment are perpendicular to each other, and that's true for all 2D problems because the force for a 2D problem is always within the plane, while the direction of the moment is always perpendicular to the plane. Therefore, because these two vectors are perpendicular to each other, I can now move this force to a specified location. Therefore, it itself creates a moment that equals to 2,530 Newton meter about point A. Because this force has two components, an x component and a y component, and because we're going to move it along the AC direction, the x component of the force does not create moment about point A. So only the y component of this force creates a moment about point A. And that y component has a magnitude of 876 Newton. Therefore, from here, we can determine the location. x bar A equals to, we're going to use the absolute value, resultant moment about point A, absolute value divided by the absolute value of Fy, because again, we determined that only the y component of this force creates moment about point A. And that equals to 2530 divided by 876, which equals to 2.89 in the unit of a meter. So now we're going to move this force. Again, we keep the same x component. The x component is going to be the same 275 Newton. The y component is going to be the same vertical down 876 Newton, creating a resultant force in this direction of 918 Newton. And this vertical component, 876 Newton, creates 2,530 Newton meter moment clockwise about point A. Therefore, this force alone replaces the previous force system. And this location from point A is 2.89 meter. How about if we do similar calculation but using point B as a reference? If that's the case, this force is going to be the same. So placed here, we will have the same force placed here. That is 918 Newton, resultant force that we determined earlier. It has the same x and y components, so same components, vertical down of 876 Newton, and along this direction, 275 Newton. But it has to create a counterclockwise moment of 750 Newton meter about point B. So now we again used a single force, a single moment system to replace the previous three forces. But this system is placed at point B. How about if we want to continue to replace the system by a single force system? We're going to move this force to a location where it creates a moment of 750 Newton meter about point B. And only the x component in this case can do that. Therefore, we need to move the x component down to this point, and this y bar B equals to the magnitude of 750 divided by the x component 275, and that equals to 2.73 meter. So now we have replaced this force right here to this new location, and this distance is 2.73 meter. If we extend this force so that it intercepts with AC. So let's see, what is this location? We know that because of similar triangle, this question mark versus this distance, which is 4 plus 2.73, must equals to 275, the x component, divided by 876. From here, we can determine the question mark, 2.11 meter. So if the question mark equals to 2.11 meter, that means that this portion equals to 5 minus 2.11 meter, which is 2.89 meter, which is exactly what we determined earlier.